Hey everyone, my name is Ankit from Department of ECE S section, and today we are going to explore one of the coolest and most powerful features in C++, which is templates. So, what exactly are templates? Templates in C++ lets us write generic code, meaning code that can work with any data type. Imagine you want to write a function to find the maximum of two numbers. Once you'll write it for integer, once you'll write it for float, and then so on. That's a lot of copy paste, right? Templates solve this problem beautifully. Then they let you write that logic once, and C++ automatically adapts it for different data types. Here is the definition for templates. A template is a blueprint for creating functions or classes that can work with any data type. This is the syntax for templates in C++. Here, template type name t tells the compiler that we are creating a generic function using a placeholder type t. Whenever you call the function, C++ replaces t with actual type like int, float, or double. Alright, before we go further, let's see what happens without templates. Here's a small example. The whole code looks fine, right? We are basically adding two numbers, that is, one's for integers and one's for double. So, but we have two functions doing the same thing. If we want to support float, long, or even char, we would write more functions, right? That's very repetitive. That's also boring, and you might even have some error in it. That's why templates are so useful. One function and any type. Now that you get the idea, let's just see the different types of templates in C++. Function templates, class templates, and templates with multiple parameters. The function templates are used for creating functions that work with multiple data types. Class templates are used when you want entire classes to work with different types. Templates with multiple parameters are used when you need more than one type at the same time. Now let's start with function templates. Here's the concept. A function template is just a function blueprint that works for any data type. The type is not fixed. It's a placeholder that the compiler fills it when the program runs. Here's a template function to swap two variables of any type. We first write the template, then we write the function, and this logic is fixed. So now basically the compiler automatically replaces the template type with actual type during compilation. Now let's have another example of getting the maximum number between two variables. Here we write the template and we write the function, right? And here we ask the code to get the maximum of 3 and 7, 4.5 or 2.3, A and Z. Here in 3 and 7, the compiler replaces T, which is the placeholder, with int. Here in 4.5 and 2.3, the maximum is 4.5, right? Here the placeholder t is replaced with double, and here the placeholder t is replaced with char. Now let's move to class templates. Just like function templates, these lets you create classes that work with any data type or any type. Here's a simple example. You create a class, and then you have the function, and then you have the code, right? Here template class t defines the class with template type t. Pair int creates the pair class for integers. In a similar way, pair double creates another pair class for doubles. And basically have you see here the same, it's the same code, right? Which works with different data types. As you can see here, nothing has been repetitive. You only write it once and you call the function when you write the code. That's it. Class template with two type parameters. What if we need two different types in the same class, like an integer and a string together? We can do that with multiple type parameters. Here, template class T1, T2 allows using of different types. In my class instinct, first data is int and second is string. And then in my class char and double, first is char and second is double. Here are the differences between class and function templates. For both of them, function templates is used for generic functions and class templates are used for generic classes. Syntax, here is the syntax. We have type name T for function template and class T for class template. Here is the example for both of them. And we have reusable logic in function templates. In class templates, we most likely use data structures. It happens when the function is called, and class template happens when the object is created. And now we have another example, combining class template and function templates. Let's say we have a class math box that stores two numbers and calculates their sum. And now a function template that compares two math boxes, which are objects. And now here we see how function and class templates can work together. Super reusable and efficient. Now let's test our understanding with few quick questions. First one, what is the main purpose of using templates in C++? Which keyword is used to define a template in C++? This is pretty easy, right? In the statement template type name T, what does T represent? Which of the following correctly defines a function template? Here, here just guess the output of this code. Which of the following is true about class templates? A class template can only use one data type, have multiple type parameters, cannot have member functions, and are used only for integers. Which one of them is right? Which of the following is correct syntax for class template with two parameters? What does the following code print? What is template specialization in C++? Which of the following statements about templates is false? So here are the answers. So to wrap up, templates are a game changer in C++. They make your code flexible, reusable, and type safe all at once. You can create one version of your logic, and the compiler automatically handles all the data types for you. From functions to classes, templates save you time, reduce redundancy, and make your code super efficient. Thanks a lot for watching my presentation.